Fermentation, measurement, automation, and innovation. Hi, my name is Greg Coutant, and I'm the Strategic Marketing Director here at Ancom Technology. It has long been understood that the efficiency of milk and beef production is directly related to ruminant nutrition. As a result, milk and meat producers are constantly looking for the most efficient diets for their animals. In the ruminant animal, a major part of the digestion process occurs in the rumen, which happens to be a large fermentation chamber. Fermentation in general is an enzymatically controlled anaerobic breakdown of energy-rich compounds such as carbohydrates into organic acids such as volatile fatty acids or VFAs, and other compounds such as carbon dioxide, alcohol, and methane, depending on the microbial mix involved in the process. In a ruminant animal, the VFAs are absorbed and carbon dioxide and methane are passed out of the animal as waste. Although there are multiple ways to assess the effectiveness of ruminant feed, measuring the amount of gas and the rate at which the gas is produced can be extremely useful, as these measurements are directly related to the effectiveness of the digestion, and therefore directly related to the value of the feed. In the early days, ruminant researchers attempted to measure the rate of gas production and the amount of gas produced using instruments based on the Warburg method. Although this kind of equipment could measure gas production and rate, it could not easily produce real-time data or store data without someone sitting and watching the instrument, which was obviously very time-consuming. This made it impractical to run long assays. As a result, many researchers tried to create systems of their own to more efficiently measure gas rate and production during fermentation. Unfortunately, many of the attempts didn't fully meet the need. Because of their widespread use of the Ancom 200 and the Ancom 2000 fiber analyzers, ruminant nutrition researchers understood the engineering capability at Ancom Technology. So they asked Ancom to engineer an automated instrument that could measure the rate of gas production during rumen digestion and determine the total amount of gas that was produced over a period of time. Ancom went to work, and the Ancom RF gas production system was born. Unlike other Ancom instruments, the RF gas production system, referred to hereafter as the RF system, was not created to directly execute any specific official method. Instead, it was created as a tool to fit into many different methods and procedures. The RF system provides the capability to test multiple samples at one time, with each sample in its own module that includes a bottle in which the reaction occurs and electronics for communicating pressure and temperature data back to a computer for real-time monitoring and for data storage to allow for analysis at a later time. Wireless technology provides users with the flexibility to place individual modules at locations away from the computer within a distance specified by the radio frequency or RF capability. This frees up valuable bench space and enables users to place the modules in water baths or incubators to better control temperature during experiments. An RF system can include from 5 to 50 modules, and you can have up to 10 different systems in a physical location without experiencing radio frequency interference. With the ability to run multiple samples at once, monitor the gas production rate in real time, and automatically store data from assays run over a reasonably long period of time, the RF system solved the inefficiencies of the Warburg-related instruments and established itself as an extremely useful automated tool for measuring gas production rate and determining gas production amount. Before we talk a little more about the markets served by the RF system, Let's watch a short video to learn more specifics about the system.
The ANCOM RF gas production system provides an easy-to-use tool for monitoring and measuring evolved gases during anaerobic fermentation or aerobic metabolism. Designed to support studies in rumen digestion, the RF system is also used to study human digestion, yeast activity, dough rising power, biomass to energy development, biodegradability, wastewater treatment, and more. The critical component of the RF system is the module used to contain samples in an anaerobic or aerobic environment. As microbes metabolize the substrate, various gases are produced. The type of gases produced will depend on the number of factors, which include the makeup of the microbial population and the composition of the substrate. Because the system allows the user to control the environment, the fermentation substrate, the microbial population, and the study variables, researchers can use the RF system to monitor gases produced over time with little intervention. Here's how the system works. Microbes, substrate, and buffer solutions are placed in the RF1 modules according to the requirements of the study involved. The modules are placed in an incubation source as needed. As gases evolve, the RF1 module measures the pressure and sends this information together with the temperature of the RF1 environment to the host computer using radio frequency technology. The gas pressure monitor software stores the data while it automatically calculates and graphs cumulative pressure and temperature in real time. At the end of the process, all data points are captured on a standard Microsoft Excel spreadsheet for analysis. The volume of gas produced can be calculated based on cumulative pressure. The custom-designed software and advanced electronics allow the user to control a number of variables: the time intervals of computer communications, the timing of data capture, the pressure and temperature units of measure, individual or global pressure release points, and more. This allows researchers to set up studies with specific parameters and run those studies with little manual intervention. The use of radio frequency technology eliminates cumbersome wires and provides greater flexibility for the user. RF1 modules can be located away from the computer and in different environments. In situations where signals are impeded, an extension antenna is provided to relocate the receiving antenna. Gases can be sampled at any time during the operation using the built-in vent or through an optional Septiport bottle to create gas profiles using a gas chromatograph or other means. The RFS base kit includes 5 RF1 modules with rechargeable battery packs and standard 250 milliliter bottles. However, you can modify the kit with different bottle sizes and types. The kit also includes a module that measures atmospheric pressure, a radio frequency transceiver, a 10-station battery charger, an antenna extension cable, extra lure caps and valves, synthetic grease to aid in creating an impervious seal between the bottle and the module, and user-friendly computer software that controls the system and captures data. Designed for expandability, up to 50 RF1 modules can be used with one base kit. The RF system provides a base kit that includes 5 RF1 modules for a low-cost entry, is modular and expandable, capable of up to 50 RF1 modules on a single base kit. This allows the user flexibility in study design and the capability to test a number of variables during a single test. Uses wireless technology that allows modules to be placed anywhere within the radio frequency range, freeing up valuable counter space for other uses. Includes user-friendly computer software that makes it simple to use the system and analyze the results. Provides real-time graphing of pressure and temperature curves to aid in monitoring kinetics at any point in time. Allows user-selected gas release points to control the amount of pressure that builds up within an RF1 module. A modular design at a low cost that is easy to configure and use. The ANCOM RF gas production system is a precise and accurate tool that can help meet your research and testing needs. We hope you have benefited from this brief overview and welcome any questions you may have. To summarize, the ANCOM RF gas production system provides a low-cost and easy-to-use tool for monitoring and recording evolved gases in an anaerobic or aerobic environment.
The RF system has been widely accepted in the ruminant nutrition markets as it was originally designed to serve ruminant researchers. However, since the system can measure the productivity of any fermentation, its use has spread into many other markets, including, but not limited to, non-ruminant animal nutrition, human nutrition, biomass to energy production, for example, fuel ethanol, brewing, yeast activity, and dough raising. Wherever there's a fermentation occurring, there is a breakdown of organic matter into nutrients and waste, including gas. Fermentation occurs in monogastric animals, for example, humans, pigs, and horses, in the hindgut or colon. As a result, many non-ruminant animal and human nutrition researchers have been using the RF system for years to analyze digestion and digestibility. Unfortunately, we know of no official methods associated with these markets, so we don't have specific procedures that we can share. However, as with rumen digestion, the amount of gas and the rate of gas production is directly related to the effectiveness of digestion. That's where the RF system has usefully served these markets. Whether producing ethanol for powering vehicles or for adult beverages, fermentation is required to break down plant material using enzymes found in yeast. Ethanol fermentation is one of the oldest fermentation processes used in the biotechnology industry. In the U.S. alone, over 4 billion gallons of ethanol are produced annually from corn and used as a transportation fuel. Based on 2017 data, the RF system is used by 3 of the top 5 U.S. ethanol producers and many more to benefit their fermentation processes. Like the fuel ethanol process, the production of consumable alcohol requires a fermentation step. The RF system is being used by many producers of consumable alcohol to test yeast and substrate quality. For a fermentation to effectively produce alcohol, it requires an alcohol-tolerant yeast that can remain active during the fermentation process. As you can see from the previous discussions, yeast is used prominently in the fermentation of alcohol. However, it's also used to make bread, where its major function is gas production. In the past, baker's yeast manufacturers have relied on instruments such as the SJA fermentograph shown below to make sure that their yeast produces consistent gassing performance. Since the RF system is designed to measure gas production rate and determine gas production amount, many major yeast companies now use the RF system for yeast and dough testing. And as you can see, Ancom has a large mouth bottle for use with dough. And many of these companies also use the system for rumen and alcohol testing, as these companies have a presence in many of these markets. With the ability to communicate accurate temperatures and pressures to a computer using wireless radio frequency technology, the RF electronics can be used to measure temperature and pressure in places other than the modules included with the commercial RF system. In fact, Ancom regularly uses the RF system electronics in their internal lab as a tool for measuring and recording temperatures and pressures in prototype instruments during new product development. Please note that Ancom does not currently have a commercially available product to measure temperature and pressure in places other than the modules included with the RF system as referred to above. However, if you have a need for this capability, please let us know. If you're interested in more information about the RF system, please go to ancom.com and select Gas Fermentation Measurement from the Product Catalog menu. When you get to the RF System product page, scroll to the bottom and click the Product Documents tab to see a list of useful and informative documents. As we wrap up, let me leave you with this. The RF system was originally created to automate the measurement of gas production rate and the determination of gas production amount associated with the fermentation that occurs in ruminant animals. Built as a generic tool, this system has been widely accepted in non-ruminant markets such as non-ruminant animal nutrition, human nutrition, biomass to energy production, brewing, yeast activity, dough raising, and more. So if you have a method or procedure that requires you to measure the rate and/or the amount of gas production, or you just want to measure pressure or temperature at some location and remotely monitor the data, this tool could be just what you're looking for.
Well, I hope you enjoyed that presentation. After this webinar is over, we want to equip you with resources that can help you. Since the RF system is such a universal tool used in many different ways by customers in 49 different countries, we can't know the details of all the applications, but we can connect you with resources that can help. The first resource, let me just get there. The first resource is the ANCOM website. When you go to the ANCOM website, you'll see the navigation links at the top of the homepage. When you click on the product catalog link, you'll see an image menu showing all of our current products. If you click the gas fermentation product, it'll take you to the RF product page. Here you'll find lots of descriptive information about the RF system. And if you scroll to the bottom of the page, and let me get there, you'll see a section with 4 tabs. If you click the Product Documents tab, you'll see a list of useful documents. The first document that I want to point out is the Operator's Manual. This manual provides a wealth of information about the RF system and how to use it. Next, I want to show you the Rapid Determination of Yeast Vitality article from Brewing Science. This article provides great information about how to measure yeast vitality using a gas system. As you know, yeast can play a big part in many fermentations, so measuring vitality is important. I also want to point out that VH Berlin did some yeast and dough studies and published their results. And those results are in the list shown here. And if you're involved in ethanol and/or consumable alcohol markets, I would recommend that you consider going to the Lallemand Alcohol School. They do a great job of pulling together experts who can provide insight into aspects of alcohol production. And if you're involved in the rumen market, I would recommend visiting Dr. Luis Tedeschi's website, as he's done a lot of work in this field. The next resource that I want to show you is the service section of the ANCOM website. So once again, if we go to the top of the screen and look at the links and we click on the technical support link, you'll see a list of all of the ANCOM products shown in an image format. When you click on the RF gas production system, you'll go to a page with great technical information, including many frequently asked questions. Okay, for the questions part of this webinar, I've been joined by our manufacturing and service technician, Joe Askins, and our Vice President of Marketing and Sales, Chris Kelly. So now let's take the questions in the order that they came in. And by the way, we welcome answers as well. Okay, so the first question, what is the margin of error between the different modules if the different modules are under identical conditions? I don't think that there's really any difference between the modules. It depends really upon where they're located and what their environment is. But if they're all in the same environment, I believe that there's really no different. There shouldn't be any difference.
We do have a resolution statement on our product information sheet. Maybe Greg can pull up that product information sheet and you can see that. And then you can see that resolution, because off the top of my head, I don't recall, but it's a good question. Is there going to be variation between modules? And theoretically, no, there should not be, as Greg said, but there is a resolution statement. Let me pull that, or Greg's pulling it up for us right now. And then go to page 2. And we show a resolution of plus or minus that 0.004, 0.04.
So the second question in that set of questions is, what would be the effect of pressure limit set on the module on the back pressure created during the fermentation? Let's say 10 psi versus 1 psi.
If that's referring, I'm not sure if I'm clear. This is Chris. I'm not sure if I'm clear exactly on the question. We do have a recommendation of having pressure releases on each module. And matter of fact, Franco, I cannot think of his last name, in Italy, one of our users actually published that relative to ruminant nutrition. And his paper basically shows the benefits of having that pressure release for the overall study. But basically, even though you have a pressure release, the transducer does catch all pressure, cumulative pressure. So you don't, even though you're releasing pressure, all pressure is captured. So you'll get and I'm looking to my team here, you get an absolute pressure as well as a cumulative pressure.
Right, correct.
So there's a pressure reading at each data point that you request, and you can get data points every, I think the lowest is 1 minute, and up to every hour, I believe. And it's in like 5 or 10 minute increments. So you have a lot of versatility of how often you want a data point. Pressure releases are recommended because you don't want CO2, for instance. Oh, thank you. Somebody's actually sent a note to everybody that's given the name. That's fantastic. But I guess the point I'm trying to make is, if I understand your question correctly, you do want to have releases because at some point CO2 dissolves back into solution if the pressure is too high.
Great. Next question is, do you have any trial results with the R510 bag in the RF system?
I don't believe we do. We do have some customers that have done some experimenting with in vitro dry matter disappearance by basically using our F57 filter bag and using that with a sample inside the RF1 module. And the goal they're having there is they want to measure the gas, in other words, the direct measurement of the gas during metabolism and fermentation, but they also want to be able to weigh back the sample to look at dry matter disappearance. And the only issue I see with that option, and the same would be true for the R510, is there any lag time for the entrance, if you will, of the protozoa and the microbes into the bag? And so from a gas pressure standpoint, there might be a slight lag time waiting for the microbes to be able to make it into the bag. That would be my only issue.
These are great questions. Thank you very much. Next question is, some of my ANCOM modules do not read the right temperature off by 40 degrees Celsius, and the temperature calibration doesn't work. First of all, thank you very much for using our system. Appreciate that. And then lastly, it says, is it going to affect the pressure reading?
Well, the first part of that, this is Joe Askins. The first part of that question is, it may be that some of your modules do not have a temperature sensor on them. Originally, they did not have them. We've now put them on. It does not affect, however, the pressure reading. The pressure reading is completely separate from the temperature reading. And that temperature reading is basically giving you the temperature on the inside head of the module. If you're in a water bath, it may be off several degrees. It's just to give you an idea of where about the temperature is currently.
Yeah, one thing to add to that is, as Joe said, it's not meant to be a pressure of your water, things like that, because we don't submerge it. We do offer extensions for the temperature sensor in order for you to have the measurement outside of the module itself. But the key is that over time it'll equilibrate to your environment if it's a closed environment. One of the reasons why we went with the temperature sensor was to be able to monitor, if you will, at a glance, if there was anything happening in the incubation system that was being used. In other words, was there a sudden drop in temperatures and things like that? Because changes in the temperatures would affect your gas production, and we want to be able to see. It's kind of a troubleshooting thing, if you will, more than anything else. But as Greg suggested in his presentation, there's been some neat applications for that temperature sensor.
Okay, the next question is there a specific reason that the system is permeable to CO2 to the point that the bottles can reach a negative pressure during a run? The only thing I can think of there is that somehow there's not sealed properly, but it's not.
We do, in the manual, we do talk about CO2 permeation in the silicone that's used for the transducer. We actually made a lot of modifications to reduce that. So it is a very small amount of permeation of CO2 during a run. But as Greg said, if you're seeing significant amounts, then that's certainly going to be because there might be a pressure loss or something. I would suggest or mention, just as an offside to this, is we have some people that are using an additional module, or maybe it's not a module, we call it the top hat, but we have a little insert that can go inside the bottle, under the module, if you will, to put something like sodium hydroxide in, which would absorb the CO2 and create a vacuum. And so it's a limited application, but some people are doing that in order to do BOD testing.
Okay, next one. A real problem is battery life. I know we can use a 2-lead system and a plug-in, but this is a move away from a wireless system. Any good ideas?
Your point is valid. And it's interesting because we have some people that are actually doing month-long studies. And what they're doing is they are changing the batteries during an operation. And the beauty of that, or the way the software is designed, is if you are, let's say you have 50 modules running, and you're doing long studies, and you're noticing the batteries are going to yellow, you want to change them. Even if data is being requested at the time you're making the change of the battery, the system holds it. Basically, if it doesn't get a response because you've disconnected the battery, it holds at the last pressure point. So once you put the battery in, it basically starts recording again, so you don't see a drop. In other words, I guess what I'm trying to say is when you disconnect the battery during an operation, it won't see a plunge. You won't all of a sudden go down. It's going to hold at its last pressure point until it gets a connection again when you do the battery.
Which means you won't lose data.
Right. Correct. The concern being brought up about, gee, if I'm doing all this work and expense and I can't trust the batteries, what do we do? Joe, you're going to have better experience in this. Yeah. What's the normal life on it? Now, by the way, this is a good point. Check your live interval on your software.
That's a very good point.
If you have a live interval, and I don't remember what the minimum is, but if you have a live interval that's set at 5 seconds, that means that the computer is constantly talking to the modules. So the longer the live interval is, or the separation of the live interval, the longer your batteries will last. But Joe, under normal circumstances?
When we run our test, we run a request every 10 minutes and a recording, or every 10 seconds and a recording every 10 minutes. And that battery life should last for about 2.5 to 3 days. The batteries come with a 1-year warranty, and like any other battery, as it gets older, it doesn't hold the charge as much. It should take about 2.5 hours to fully charge one of those batteries when it's completely discharged. If it charges sooner than that, then you may want to replace your batteries.
1 minute and record every 10 minutes. I would not see that. That should give you a longer life. That can you tell us what your die time is? If that's a term.
Going back to that 1 minute and 10 minutes, it depends also the age of your batteries. We found here that if batteries are over 2 years old, they start losing their charge a lot quicker. They'll continue to work, but they won't work as efficiently as if they're just a year old.
Okay. By the way, there's an answer to the question we had, but then there's also a repeat or a clarification asked about the vacuum, and that person made a very good point. Correct me if I'm wrong. having a not perfect seal shouldn't necessarily give you a vacuum, because it can't have a vacuum because it has no ability. So that we misstated. That's a good point. That should not be the cause of a negative. The negative's got to be caused because there's something absorbing the CO2, like the sodium hydroxide I talked about in certain applications. But I'd have to know your specifics. That might be something we might want to follow up with you on specifically, and see if we can come to the reason why you're seeing a negative. So do we have a time here yet on that battery? We think
It should last for about, like I said, 2.5 days. If they're within a year old of being purchased and they fully charge, it takes 2.5 hours after they're discharged. The other thing to remember is you need to have them discharged fully before you charge them again. And many times, if you just keep pushing, recharging them before they're discharged, it's going to shorten the life of the battery also.
okay, and I think here's the answer. It says we have to charge
Change
3 to 5 batteries each run, 48 hours. So, and I don't know what your total number you're running, but you're basically saying 3 to 6 of them you're saying are running out during a 48-hour run, and you're obviously doing a good job of tracking the batteries. Okay, 50 units, and you're replacing 3 to 6. That might be something we might want to look at your batteries, and if based on the age and things like that, if they're less than a year old, we're going to replace them for you for no charge, and see if it's, it could be a bad battery too.
And you can find the age of your batteries by, if you pull back the flap on the battery label, it has a date handwritten in there, and that'll determine what the ages are.
And Joe, why don't you address the charging process, because you want to make sure the batteries are fully charged before the run, because if they're sitting on a shelf, there is power loss over time. So you do want to charge them up front. But what is the impact of up and down charge? Do they have to be fully discharged before you charge and things like that?
They need to be fully charged before you use them. And on your battery charger, there's a red light showing you that it's making connection to the battery charger with the battery pack. And then when it's fully charged, it turns bright green.
Okay. The next question is, have there ever been reports of other equipment interfering with the wireless communication?
Yes, we have found that there are sometimes interference, and it can be as easy or as simple as dirty power. We found that if somebody runs the extension cable for the antenna along a power drop that's along the wall, and they run it on top of that, just that can cause the RF interference. But as far as microwaves or those things close by, we haven't experienced much problem with that.
And we have Wi-Fi in our operation throughout the whole building, and we don't see any interference from that. There has been, and it was alluded to in the video, depending on how much steel and concrete and rebar between where the modules are and where the computer capture is, that can create interference. By specification, straight line view of the RF can be like like a mile or something. It's a ridiculous amount, but that's straight line, no interference, no walls and things like that. But if you got a lot of concrete on its own is not a problem, but rebar, we had, matter of fact, Franco in Italy had an initial problem in the early system, and he had his modules in steel ovens with steel racks and closed door, and the only way that could be solved was by that extension cable.
Okay, the next question is, what would you recommend to fully drain all the batteries after each run prior to recharging them?
Leave them connected to the modules and the software up and running, and it'll show you when it gets down to below 6 volts. And at that point, it turns yellow, and that's when you would charge them.
And I wonder if the question is, should they discharge them before? Because like NiCad batteries used to have to discharge fully.
You don't.
These are not.
You do not have to discharge them fully.
So you don't have to do it, but the key is to make sure you do have them fully charged before you use them.
And if they are fully discharged, if they're down to the yellow, then it generally takes 2 to 2.5 hours for them to recharge. And if they're recharging quicker than that, within an hour, then those batteries are showing they're getting older and they're not holding a charge fully. It will look like it is when you attach it to the battery charger. The light will go green real quick and it says fully charged. You'll put it on the system and it will say that it's 6.9 or 6.8, but you will see it was discharged much quicker than a new battery was, so it'll discharge within an hour.
Yeah. We're very glad that the new software that we did that actually allows you, if you do have one of those drop-offs, that allows you to capture data that you think is lost. So I'm glad that you've not had any issues with that. But yes, to clarify your point, as Joe said, you don't have to fully discharge the battery to charge them.
Okay, next question, follow-up question on setting the pressure limit for fermentation to avoid CO2 accumulation and dissolution in the medium. Do you know of any resource or application of ANCOM for ethanol production that recommends what pressure to set so that this does not happen?
And you're talking about the global release or the pressure release. What's our recommended just overall? Do we say 1 PSI?
1 PSI,
1
correct.
PSI is the We're not the experts in ethanol. We just have to be honest about that. And maybe somebody within the group here might be familiar with some of the dissolution type issues. But as we said, we recommend 1 PSI as a general release point.
Correct. Okay, any other questions?
Let me throw one more thing in here because of that question for those of you doing the ethanol. One of the beautiful things about this system, if you're running multiple modules, is you can test things at different points and basically kind of come up with the research on that. So if you had, 15 modules, you could have 5 with a 1 PSI release, 5 with a 5 PSI release, and 5 with say 8 PSI. I don't think we ever want to go over 10 PSI. Correct. In that. But in other words, you could do multiple pressure releases because each individual module can be controlled separately. You don't have to do global pressure release. You can experiment. So that might be a good research option for you.
I want to go back to the batteries and the reason for discharging them. It's not that they require to be fully discharged, but if you want to find out if the batteries are holding a complete charge as long as they should, that's why you go down and see that they're discharged down to below 6 volts, and then test to see how long it takes to charge them. If it charges before an hour and a half to 2 hours, then you're going to need to replace those batteries. Because what will happen is they will start the software and it will run, but there will not be enough power to engage the solenoid pinch valve when it needs to release the pressure.
Okay, but the green light goes on long before the 6.9 level.
Well, then that's telling us that the battery is possibly bad.
Okay, is the RF system a stock item or built to order? And if so, what is the lead time?
It's a stock item. We state that there's a 2-week lead time, but generally we can get out an order within the same week that we get the order given to us.
And also, though, just to clarify a little bit on that as well, although it's a stock item and the RFS comes with 5 RF1 units, you can order it with up to 50 RF1 units included.
And you can order up to 5 systems at one time, or
Correct.
10 systems at one time.
Now, that's actually a good point since we're talking about this. If you have a system currently, and let's just say you have the base kit, which is 5 modules, and you want to order additional modules, you want to expand your system, we then need to know your serial number and your network, because we have to make sure each new module is programmed for your system. So there is a sense of building to order when it comes to adding on after the fact.
Okay, next question. Is there a way to pull gas from the bottles and still have it count up from the previous measurement?
If I understand your question, if you draw gas or either gas or liquid from the headspace of the RF module from a SEPTA port, you are going to have potentially a dip in the pressure because you're doing it before the transducer. And if you're taking liquid, you're changing the headspace. But if you draw it from the vent valve using a lure lock and a gas-tight syringe, then you will not have a dip in that because it's drawing it after the transducer.
But if you leave it on there too long, sometimes it can equalize and the pressure not release. We've seen that happen. When you have something attached to the exhaust and you don't immediately take it off, sometimes they'll leave it there. If you leave it attached to it and not take it off, it can equalize with the pressure inside the bottle and then nothing happens.
These are great questions. Anything else? Okay, well, if that's the end of our question time, again, I just want to say thank you so much for sharing your time with us. And as a follow-up to this webinar, we'll be sending you all an email with the recorded webinar link for you to view at your convenience. We always invite and appreciate feedback, so please feel free to send us your thoughts and comments, and We hope you have a great rest of the day. Thanks again.